Morning, YouTubers. On today's video, which is going to be probably the last flux core video for a while, we're going to do a viewer request, and that's welding thin to thick metal, or basically differing thicknesses, how to weld it. Well, you've seen I've welded thin or thinner, a 16 gauge, a 16 gauge. That's not too hard. But what about welding a lot thinner than that to say thicker than that? So what I have here is a bunch of assorted thicknesses of metal that I'm going to cut up into test coupons. I have 16 gauge, 22 gauge, 1/4 inch, 1/8 inch. I'm going to cut a bunch of test pieces out of here, and we're going to try and stick it together. I don't have too much hope on the 22 gauge, you never know, but I'll give that a shot to see. But I think you'll actually be surprised at what you can do with flux core wire if you know what you're doing. I'm definitely hoping that the 1/4 inch to 16 gauge, I'm pretty sure I can do it. But like I said, this is kind of a fun experiment, viewer request, so we're going to find out together what is and isn't possible. Let's get into it. So theory-wise, what you're going to find is your ability to weld a thicker to thinner piece. Not only does it rely on, well, the disparity between the sizes, and obviously the thinner you go for either piece, the harder it's going to be, but it also depends on how you're welding it. So like in this, where the thicker piece is on the bottom than the top, you're going to want to focus more of your heat into the thicker plate, which may mean taking your wire angle and bringing it slightly like this. You can also take, and let me get a better position here. No, you don't weld like this, but this is so I can demonstrate. You can also, by doing a small circle motion, weld primarily on the bottom plate that's thicker, bring it to there, and it can even work like this. So you're back here, bring it a little bit, little bit, little bit. That way your weld and your heat is focused more in this bottom plate than the top. It's really all about control. If you can keep the heat mostly on here and get enough of it to come over with the weld to wet in and tie into the thinner piece, that's great. Now this is where you're welding the thicker on the bottom. If you reverse them, you would want to focus more on the top plate and then bring the heat down like this. Bring the molten puddle down. Again, the bigger the disparity between the thicknesses, the harder and harder this is going to become. So it's not, it's not going to be easy. In a lap weld like this, if you're welding thinner to thicker, this would be probably the easiest of them all. You would just focus as much as you can right on this top and bring it down, bring it down, bring it down, such as that. That would make it a lot easier. Now, if you reverse this and you wanted to weld the thin to the thick, I would probably primarily focus more of an upright angle rather than this, and then circle from this onto there. Or in theory, you could even run it down the edge of this plate and likely burn this plate, melt the edge off right into here. You're going to have to experiment with that. If you're welding, probably the more difficult would be like vertical up, such as this, or even outside corner joint would be tough, but let's do vertical up. The issue here is that, well, this imparts more heat anyways, so you're going to want to likely weld at slightly reduced settings, and you're going to focus more on the thicker plate and just come over a little bit, just like this. And you're going to have to manipulate the puddle in order to get it to wet into here, but not blow a hole through. It's also worth noting that if you have any kind of gap, like if you have a gap like this and you're trying to weld a thin to thick piece, good luck. I mean, you'd be better off running a bead on the thick plate and then like a couple to bring it up to touch than you would be to attempt to try and bridge the gap. I mean, you're going to have to run such reduced settings and your heat input's going to go through the roof. It's just, you're going to be chasing holes around. And again, this is primarily I'm talking about with flux core wire welding. okay? If you're MIG welding, you have a lot more leeway than with flux core, because you can change your settings and you can run super thin like 025 or smaller wire, MIG wire, and there's a lot of things different about the process that allows you to control your heat input a little bit better. Or with TIG, you can pretty much weld, I mean, virtually any gap in by controlling your arc, because you have a foot pedal, you can control your penetration and your heat input, but we don't have that luxury, do we? So that kind of sums up what I guess you really need to know. Let's actually do some welding now. All right, so I have the welder at E and like 4 1/4 for settings. The problem is that, well, what do you set your settings at for this when you have thick and thin? The answer is, well, if you set it for the thin, you're not going to have enough heat to melt the thick, and you're going to have a cold weld. And if you set it as though you're welding the thick, you're probably going to blow a hole in the thin. So you want to go, I would say, 70 to 80% towards the thick piece. And what I mean by that is you definitely want the settings higher than what your machine recommends for the thin, but just a little bit under what it does for the thick. Now you may be able to weld it if they're close in size with the thick settings, no problem, and just manipulating the puddle will help you. But you have to experiment with this. You know, I can't tell you, you know, the exact settings you need for every joint. You have to try enough and fail enough times to get good to where you know how your welder settings-wise performs on certain joints. It's just experience is what you need. So I'm going to run somewhere between 4 and 5 welds on here with different settings and different manipulations, and we're going to see how that works. One thing I'll say before I start here, a good way to get an idea if you're even close in settings is when you tack, if that tack blows a hole clean through the thinner material, then there's no hope of you welding with those settings. I mean, you're going to blow a hole instantly. So that's very telling. If your tack welds decent, then you're probably close to the settings you need. Just so you can see here, that's a pretty decent looking tack. It didn't quite blow off the corner, did nip it a little bit. This guy, pretty good. So we're in the ballpark of where we need to be. Now, I'm going to keep this plate off of this far enough, because if you touch that up, it's going to act as a heat sink, which it's also worth saying, if you're having issues blowing holes, take a bar of aluminum, put it on the back. That will absorb enough heat to where it'll prevent you from blowing holes. And if you do, the weld from this will not stick to a bar of aluminum. However, you have to keep in mind, like, that might give you the ability to do a test weld, but if you're actually working on a project, will you be able to get a piece of aluminum clamp to it? You may or you may not, so you can't use that as a crutch all the time. It's just something to think of. So our first attempt, let me clean this off a little bit, went pretty good. We have very little to no melt through. Pretty big weld deposited. Now, I didn't know what to expect doing this, so what I ended up doing was coming in as a zigzag. I started here, I brought the puddle and the arc back onto the plate, and then I brought it up. So kind of like in an exaggerated movement to tie into the top plate. That actually welded pretty good. So what I'm gonna do is I'm gonna start down here a little bit and just try and run straight in and see what it does. So this was run straight in with just a slight oscillation. And there isn't very much risk of blowing holes in here. So the disparity between these are close enough that this is pretty easy to weld. Now the back side, couple pin dots coming through. So I think we can actually up the settings a little bit to try and get a little bit more fusion in there. So I'm gonna go up to E and a quarter, 4 1/4. Whether that actually makes a difference with the machine, I'm not exactly sure. And I was slightly favoring the bottom plate than the top plate. I'm gonna try and come in a little bit closer to like a 45-degree angle and see how that works. So if you look there, it seemed to make a slight difference. It seems to be run a little bit hotter, a little bit more neck down. But overall, that's looking real good. Not really any more melt through in the back. I mean, a couple more spots of it, I guess. So that's not looking too bad. I mean, these settings right here are ideal for what we're doing. Since that's going pretty well and don't really have much of an issue, what I'm gonna do is I'm gonna position this and then weld it vertical up, and we're gonna take a look at that. Same settings, no changes. After we do that, I'm gonna switch it up and try and do, I don't know, maybe 22 gauge to 1/4 inch we can try. We'll have to see. When welding vertical up, and I didn't clean it that well there, you're gonna notice that the weld, the travel speed I have to increase, which necks down the width of the weld. You can tell by the back side, if I can get that position, much more penetration through simply because of the heat soaking of the material. But overall, same settings, didn't change anything, was able to weld vertical up. Had I taken more time and let it widen out to where it's equal in width as these, I would have probably blown a hole. So reducing settings and slowing down a little bit may have helped. But you can see, not the hardest thing to do, and this is 16th to 8th. Let's do a little bit more of a disparity between the sizes and see if that's possible as well. All right. Because I'm a glutton for punishment here for you guys. I got 22 gauge and 1/4 inch. Look at the difference there. Now, I don't even know if this is possible. This is definitely gonna be a challenge. I know with TIG welding I could do this. There's no doubt I could do it with TIG, but flux core wire, I think this is gonna be a little bit too much, but doesn't mean that I can't try. And it's all right if you guys laugh, because I'm gonna be laughing here in a minute. Hopefully, I'm hoping I can get at least like a 1/2 inch weld on this, but who knows. Yeah, that's not good so far. Just blowing the corner off of it. Remember when I said that if the tack weld doesn't go well, you're in for a treat? I'm gonna lower the settings by a lot. So I'm gonna go to D1/2 and 3 3/4. Hopefully get somewhere. Yeah, it almost instantly blows away. I mean, it's tacked, but hope and a prayer is holding that together. I'm gonna try and reduce it even more. All right, so I've reduced it to like B1/2, close to C and 3. I'm gonna take a torch here, set this back, and I'm gonna heat up, if the tack even holds, I'm gonna heat up this base material and then see if I can get this to go. And I'm gonna say that even reducing settings, you can see what's happening. So as soon as the heat gets close to that, it just chews right through the plate. And then this is so cold, ooh, that's hot. It's not even wetted into the quarter. So this, I would say, I'm not disappointed in myself at all. This is quite the challenge. That's not gonna be possible, at least for me right now. With TIG, you actually probably could do that. Someday I'll have to try it. So what I'm gonna do now is let this cool. I'm gonna grind this flat, and we're gonna reverse this piece, and we're gonna try 1/16 to quarter. So that's a little bit more of a doable range, I think, than this 22 or 24 gauge. All right, we're gonna go back to our previous settings of C1/4 and 4 1/4. That seemed to work pretty good, and that's what we're gonna start with. So the tacks didn't blow apart. It nipped the corner a little bit there. So again, what I'm gonna do, I'm gonna heat this bottom plate just a little bit. The reason for that is that the settings we're running are not gonna provide much penetration to this thicker steel here. By preheating it a bit, it will help it wet in there. And since the top plate isn't fused to the bottom plate, if I'm quick about it, the bottom plate will maintain a lot higher heat than the top. Therefore, this preheat will only affect the bottom plate. So the weld on that actually worked really good. Ooh, that's hot. Now the penetration out the back, we're chewing up the edge pretty good, like it's wanting to come through there, so we're on borderline the right amperage. A little bit more, we'd be making holes. Get that, there you go. You can see that a little better. So I think that's pretty good. I know I can run more of that in a flat position, and you can see how the thick to thin. That preheat on this lower plate really helps. Not to mention the thickness of this will allow you to run slightly more amperage because it will pull the heat out of the molten puddle and solidify that faster. It's just in the previous test, which was, I don't know, 40% thinner than this, it just was too much for the disparity. But I'm gonna weld this vertical up now. It's hot. And we're gonna see if we can do that. let's take a look. I could have slowed down my travel speed a little bit. There's still a lot of flux on there on the edge, but if I can get the light, there we go. Yeah, I think I should have slowed my travel speed down a bit more into this bottom plate than this top plate. The backside, and actually maybe not, backside shows some, or we're blowing through quite a bit, so maybe that's why it looks like that. It's sinking in due to the penetration. Well, let me weld the rest of this. Where I don't have the camera in my face, and see if I can't improve that a little bit. All right, so here we go. That is the last bit. The last about, you can see where I botched a tie in a little bit. But yeah, I mean, that's looking pretty good. Now, the weld is laying more on this thicker plate than it is the upright, which is kind of okay. Now, normally if you're welding the same thickness for both plates, you would want it to be equal height. But since this is so thin, the fact that we didn't tie in exactly at a 45 angle is okay because this is so thin. But I mean, see if I can't get that. Difficult to get a good, there we go. Yeah, I mean, like, I'm really happy with that. Now the melt through on the back, hopefully I don't burn myself, you can see is about the same, maybe a little bit less. A little bit less, I would say, than the previous weld. But yeah, that's looking pretty good. Well, let's finish up this video. What did we learn today? Well, I learned that there's quite a broad range of material you can weld with a 125 amp flux core welder. I honestly didn't know if I could weld 16th inch to quarter and make it work. Well, this clearly shows, especially that last bit, even though it's done vertical up, it's more than doable. And it also looks pretty decent, same welding at 16th to 8th. So yeah, the 22 gauge, that's a little bit different of an animal. This might even be 24 gauge. This paper thin stuff, that's going to be a lot harder. I mean, maybe I could figure out a way to make this work with enough screwing around with settings, but for all practical purposes, I would say doing this to quarter or even to probably 8th, you're in trouble if this is what you're working with. So not so much that, but what you saw here worked pretty good. Hopefully you learned something. If you got any questions, comments, leave them down in the box. You know where to go with them. Thanks.